This question was asked in GATE 2019 electrical engineering paper, in which you have given an ideal op-amp and you have given the value of V1 and V2. Then you need to find out the output voltage Vout. The NPTEL reference for this question is Basic Electronics by Professor Chitralekha Manta, IIT Guwahati. So the useful data for this question is that ideal op-amp has zero input current because of high input impedance. Suppose if you have an ideal op-amp, it's inverting and it is non-inverting terminal, then no current will flow to the op-amp. There is no current. So the second useful data for this question is gain of inverting and non-inverting amplifier. So if we have given an inverting amplifier, so this is your plus terminal and this is your non-inverting terminal, and this is your inverting terminal which has V in, which is connected through a resistance R1 and a feedback resistor as R2. Then this output Vout will be given by minus R2 over R1 times V in. Similarly, if you have given a non-inverting amplifier, this is your inverting amplifier. If you have given a non-inverting amplifier, which can be drawn like this, minus this is your resistance R1 and this is your feedback resistor R2 and this is ground, and at the non-inverting terminal you have given input Vn. Then output Vout will be given by 1 plus R2 over R1 times V in. Now the third and most important data for this question is that superposition. So in the superposition, if we have given a two independent supply, one is V1 and one is V2, then while calculating the output you can use superposition rule. So what is the superposition rule is? So you can take responses Vout1 plus Vout2. You can take Vout as Vout1 plus Vout2. So what is Vout1? It is output due to only V1 is acting and V2 is 0. And this Vout2 is output only due to V2 given V1 is 0. So while calculating Vout1, you need to short circuit this V2 and calculate the response Vout, which is Vout1, and then again you can V1 as 0 and calculate the response due to V2, which is your Vout2. So this is the superposition rule in op-amp circuit, where the more than one supply is given. You can use this superposition principle. So in the question you have given this is your 100 k ohm resistor and this is your V2, this is your 10 k ohm, this is your 100 k ohm, and this is V1, and this is also 10 k ohm resistor. So you need to find out Vout given V1 equal to 10 millivolt and V2 equal to 50 millivolt. So this V out is your V output due to V1 and V output due to V2. So to calculate V out 1, you will short circuit this V2. So your circuit can be drawn like this. This is your 10k ohm, this is your V1, and this is ground. This is 10k, this is 100k ohm, this is 10k ohm, this is ground, this is your non-inverting terminal, this is your inverting terminal, and this is feedback resistor 100k ohm. So this is your V out 1. So in this you can see this is your non-inverting amplifier, which gain can be given by or minus R2 over R1 into V1. So this is minus 100k divided by 10k ohm times V1. V1 is 10 millivolt. So this is your output due to V1. Now in the second, when you take V1 as 0 and this is your V2, this is your 10k ohm resistor, this is your 100k ohm resistor, and this is your R1, that is 10k ohm, and this is connected to, and this is your 100k ohm, and this is your V out 2, which is nothing but when you sorted this V1, this is the output due to only V2. So this is your configuration of non-inverting amplifier, except that you need to find out the voltage at this point. So the output of this V out 2 can be given by 1 plus 100k divided by 10k, that is 1 plus R2 over R1, that is the gain of non-inverting amplifier, times V prime, where V prime is the voltage at the non-inverting terminal. So how will you calculate this V prime? So you have given this V2 and this is 10k ohm and this is 100k ohm. So this is your nothing but voltage divider circuit, which can be given by V prime equal to 100k times 100k plus 10k times V2. So V prime is 100 divided by 110 into 50 millivolt, which will be 500 upon 11 millivolt. So when you put V prime in V out 2, then you will get V out 2 as 1 plus 10 into 500 upon 11 millivolt, which will give you 500 millivolt. So now you have V out equal to V out 1 plus V out 2. So V out 1 is minus 100 millivolt and V out 2 is 500 millivolt. So total output will be 400 millivolt. So the correct answer for this question is option B.